3 colossal coronal mass ejections, each a billion-ton surge of solar plasma, were just hurled from the far side of the Sun, all converging on one interstellar wanderer. 3I Atlas. And then, silence. No change in trajectory, no flicker in brightness, not even the faintest drift. The Sun, however, did react. Its corona pulsed, its magnetic field twisted into strange spirals of heat and light, as if something invisible was pushing back. How can an object no larger than a city block withstand the full wrath of our star, 3 times in a row, and emerge untouched? Tonight, on November 2nd, 2025, new data from heliospheric monitors confirms what no one wanted to believe. 3I Atlas remains precisely where predictions said it would be. Not deflected, not delayed, unmoved. Stay with me until the end, because what we're about to uncover could change how we understand not just interstellar visitors, but the Sun itself. If you've been following this mystery, hit like, share this signal, and tell me where you're watching from, because tonight, the universe may have whispered back. Part 1. The impossible stability. Something is moving through the inner solar system right now that, by every law of physics, should not be there. I don't mean it shouldn't exist. Interstellar visitors happen. We've seen them before. I mean, it shouldn't be behaving the way it is. Because according to everything we know about orbital mechanics, plasma physics, and the brutal precision of solar dynamics, 3I Atlas should have been flung off its trajectory the moment the Sun unleashed even one of those billion-ton blasts of charged fire. Instead, it glides through the storm like a ghost. Let's back up for a moment, so you can understand exactly what we're dealing with. On July 2nd, 2025, the Solar Atlas Array in Chile registered a faint, slow-moving blur just above the southern ecliptic. At first, it was nothing special, one of countless dots telescopes pick up every week. But within hours, the algorithms screamed anomaly. This object wasn't looping around the Sun. Its path was wrong, too sharp, too clean, too open. The calculations showed a hyperbolic trajectory, the unmistakable signature of something not bound to our solar system, an outsider, slicing through our neighborhood before returning to the galactic dark. That made it the third confirmed interstellar object ever detected, after Oumuamua in 2017 and Borisov in 2019. Its official designation, 3I Atlas. Even the name felt cryptic, a cipher rather than a label, and yet as days turned into weeks, astronomers realized that what they were tracking wasn't just statistically rare, it was physically impossible. You see, hyperbolic visitors are supposed to follow predictable gravitational curves. They come in fast, dive toward the Sun, heat up, outgas, then leave, usually altered ever so slightly by solar winds and radiation pressure. But this one didn't flinch. Its eccentricity is measured at around 6.2, absurdly high. For reference, anything above 1 means an object isn't gravitationally bound to the Sun. 6.2 means it's racing through the solar system like a skipping stone, too fast to be captured, too clean to be random. It's moving roughly 60 kilometers per second relative to the Sun's rest frame. That's 135,000 miles per hour. And yet, every time new data came in, the orbit fit perfectly. No drift, no acceleration, no deviation. By late July, the European Southern Observatory had joined the effort, along with the Nancy Grace Roman Space Telescope, which had recently been brought online to monitor faint transient objects. Together they confirmed something eerie. 3I Atlas wasn't just brightening, it was brightening on schedule. No comet does that. Outgassing is chaotic. Sunlight hits unevenly, jets fire, surfaces crack. Brightness wobbles, comas breathe, tails flicker. But not here. The light curve of 3I Atlas was as regular as a metronome. If it were artificial, you'd call it calibration. If it were natural, well, you'd call it wrong. Then came the first round of spectroscopy. The readings from the Subaru telescope in Hawaii and the Las Campanas Observatory in Chile revealed an unexpected composition. Instead of the usual water vapor and carbon monoxide mix, 3I Atlas was venting gas, unusually rich in carbon dioxide and molecular nitrogen, a fingerprint we don't often see, even in our own Oort cloud objects. That combination suggests a world that once formed in warmer conditions, closer to a star, where volatiles like water ice had long since boiled away, leaving behind more stubborn compounds. In other words, 3I Atlas might be the fragment of a planet that died long before our Sun was born. By August, it became the most closely tracked interstellar body in history. The Solar and Heliospheric Observatory repositioned its coronagraph instruments to prepare for conjunction. Every agency wanted a look before the object swung behind the Sun in late October. On October 4, 2025, 3I Atlas made its closest approach to Venus, passing less than 4 million kilometers from the planet, close enough that the Akatsuki orbiter briefly captured its faint tail glowing in ultraviolet. Everything matched the prediction. Every pixel said, "The object is exactly where it should be," and then it disappeared. From Earth's perspective, it slipped behind the Sun, the phase known as superior conjunction, when an object moves behind the solar disk and vanishes into glare so intense that no optical telescope can follow it. For most comets, that's the end of the story. You lose sight, wait weeks for it to emerge, and hope the orbit still makes sense. But this time, astronomers didn't have to wait. Using data from GOES 19, Stereo B, and Japan's Hinode Observatory, they could still monitor the Sun's outer corona, and anything small enough to cast a faint echo within it. And right there, nestled in the edge of the coronagraph's shadow, 3I Atlas appeared. Just a faint smudge of reflected light, but unmistakable. Frame by frame, it crept through the boiling plasma halo surrounding our star, the most hostile environment in the solar system, and then, without warning, the Sun erupted. 3 coronal mass ejections back to back to back, launched from active regions on the far side of the Sun. Not from the hemisphere facing Earth, but from the very sector of the Sun where 3I Atlas was moving. Each CME carried billions of tons of ionized matter, tangled magnetic fields, and energy equivalent to billions of nuclear detonations. In other words, the Sun fired 3 bullets, and when the light and radio echoes cleared, 3I Atlas was still there, not offset, not slowed, still perfectly aligned with its pre-calculated orbital path. That's the moment this stopped being an astronomical event and became a mystery. Because when you hit something that small with plasma that dense, you expect a reaction, a deflection, a drift, at the very least a flicker of instability in its coma. But instead, it was the Sun that blinked. Magnetic flux spiked. Solar wind velocity changed polarity for nearly an hour, and the only fixed point in that chaos was the object itself. So the question is no longer what 3I Atlas is. The question is, what does it know that we don't? If you think that sounds like science fiction, remember this. Physics isn't a list of laws. It's a list of things that haven't yet been broken. Whatever just happened in that narrow corridor between the Sun and interstellar space suggests something unprecedented, an interaction we can't yet describe with math, maybe electromagnetic, structural, maybe something we don't even have words for yet. Astronomers have begun calling it the impossible stability. And as trivial as that phrase might sound, it represents a shift so profound that if it holds, textbooks on celestial mechanics will need rewriting. Because nothing, not a comet, not a rock, not a piece of drifting ice, should be able to shrug off the fury of the Sun itself. Yet here it is, still moving, still silent, still perfect. For now, the world watches and waits. Somewhere, deep inside that speck of dust and ice, there might be a secret, a property of matter we've never encountered, a configuration of plasma that defies expectation, or maybe something more deliberate. Whatever it is, the Sun noticed, and that might be the most extraordinary part of all. Part 2, Tracking the Interloper. Before we start imagining impossible physics or alien artifacts, let's ground ourselves in what we actually know. Because the strange part about 3I Atlas isn't the data, it's the way the data refuses to misbehave. Every number checks out, every frame aligns, every prediction holds. If this object were truly random, it would have stumbled by now. But it hasn't. When the Solar Atlas Array first picked it up on July 2nd, 2025, it appeared as a faint smear against the background of southern stars. The movement was barely perceptible, half a pixel shift every few hours, until the system's automated software flagged something curious. The parallax didn't fit. It wasn't bound to the Sun, it was just passing through. Within a day, telescopes across the world joined the chase. The Very Large Telescope in Chile, the Subaru Observatory in Hawaii, and the Pan-STARRS network all took rapid follow-up measurements. When the orbit solvers ran the numbers, the output made researchers pause. Eccentricity, 6.2 perihelion, 1.34 astronomical units just inside Venus's orbit. Velocity, roughly 60 kilometers per second relative to the Sun. That's not just fast, it's ancient. That's the speed of memory itself. It means 3i Atlas has been drifting between stars for billions of years, maybe longer than the solar system has existed. A relic of some forgotten origin, slingshotted by the gravity of worlds that are no longer there. The Roman Space Telescope confirmed the trajectory with its wide-field infrared array, and for a few weeks, the world quietly fell in love with this tiny visitor, an icy ghost wandering through our neighbourhood. But as the data sharpened, so did the discomfort. The shape of its orbit was textbook perfect. Too perfect. Natural bodies wobble, they spin, they release gas unevenly. Yet the path of 3i Atlas remained an unbroken curve, predictable to fractions of a second. It was as if the Sun's gravity wasn't pulling on it, or if something else was gently correcting its motion. By late July, the object's visual brightness began to rise as it absorbed sunlight. That's normal for comets nearing perihelion. But the curve of its rise was unnaturally smooth, a flawless exponential increase that fit no known sublimation model. No outbursts, no flickers, just steady, perfect brightening. Then the Hinode Solar Observatory recorded a faint plasma disturbance ahead of its predicted position, a filament twisting in the solar wind as if space itself were adjusting. Not proof, not even strong evidence, but enough to make people pay attention. Astronomers used to joke that interstellar objects were like cats. They did whatever they wanted and never came back. 3 Atlas, however, behaved more like a metronome, precise, deliberate, serene. So, the tracking began in earnest. Each night, ground-based telescopes refined the orbit, running complex integrations to account for radiation pressure, solar tides, and gas outflow. None of it mattered. The orbital residuals, the differences between prediction and observation, were so small they disappeared into rounding errors. Then, something strange happened. In mid-September, a new cluster of magnetometer satellites deployed by the European Space Agency detected a persistent fluctuation in the interplanetary magnetic field, synchronized with the object's predicted position. The fluctuation pulsed every 11 minutes, matching the spin rate previously inferred from photometric light curves. That's when a few researchers quietly asked the question no one wanted to say aloud. Is it generating its own magnetic field? No one dared to publish it, but the possibility lingered, an idea too absurd to be dismissed, too elegant to ignore. By the end of September, 3 Atlas was approaching Venus. The planet's atmosphere offered a rare chance to observe reflected sunlight off its tail, which, according to early images, stretched nearly 60,000 kilometers across, thin but incredibly symmetrical. The Akatsuki orbiter, running on its backup camera array, captured a faint ultraviolet glow tracing the object's path. When processed and aligned, the images showed something breathtaking, a plasma tail that bent toward the Sun, not away from it. Every comet's tail points outward, pushed by solar wind and radiation. But this one curved inward, as if drawn by the Sun instead of repelled. That single frame, broadcast quietly to research teams in Europe and Japan, broke the mood of casual curiosity. It meant something fundamental about this object was interacting with the Sun in reverse, yet the trajectory didn't change. It continued along the same hyperbolic line, right toward its predicted perihelion point, October 28, 2025. And then came the conjunction. From Earth's perspective, 3i Atlas moved directly behind the Sun, swallowed by blinding light. Optical telescopes went silent. Only coronagraphs, instruments designed to block out the Sun's disk, could see anything at all. The Solar and Heliospheric Observatory, positioned at the L1 Lagrange point, began taking continuous frames. The GOES-19 spacecraft recorded solar wind activity, while Stereo B, orbiting off-angle, caught a few blurry streaks crossing its detectors, and in those streaks was 3i Atlas, small, faint, right where the model said it would be. Then, just before it should have vanished completely, the Sun changed. A tremor of light rippled across the solar corona. Active regions on the far side began to twist, releasing energy like coiled springs snapping loose. 3 coronal mass ejections launched in rapid sequence, flaring across the dark face of the sun that no one on Earth could see. Each one followed a path that, when projected, intersected perfectly with the predicted location of 3I Atlas, as if the sun were firing directly at it. For almost 8 hours, space weather monitors lit up. Plasma velocity doubled, proton density surged, but the object never blinked. When the coronagraphs cleared the noise, 3I Atlas reappeared on the other side of the sun, precisely where it was expected to be. No deflection, no acceleration, no spin-up. It was as if those titanic bursts of solar fury had passed through it or around it, leaving the tiny nucleus untouched. That's not supposed to happen. When a CME hits a comet, it compresses its coma, strips dust, and leaves visible changes in its trajectory. Even a minuscule momentum transfer would have shifted its position by thousands of kilometers over a few days. But 3 Atlas didn't move at all. The calculations matched to within a few arc seconds. Precision so tight it bordered on absurd. So, what happened? Either the CMEs missed completely, an extraordinary coincidence given the alignment, or the object has properties we don't yet understand. Some proposed that the nucleus might be far denser than assumed, perhaps metallic or crystalline rather than icy. But that wouldn't explain the stability of the tail, or the way the sun's magnetic field seemed to ripple around it instead of through it. Others suggested the CMEs were deflected magnetically, as if the object had a protective sheath, a kind of plasma cocoon. A few even speculated about electromagnetic resonance, that the object somehow coupled with the sun's field, redirecting the energy rather than absorbing it. But at this point, speculation was all anyone had. By November 1st, the object had fully emerged from conjunction, bright but steady, sailing outward toward the orbit of Earth. Dozens of observatories resumed tracking. Every single one reported the same result. The trajectory remained perfect. No deviation, no spin, no decay. Whatever 3I Atlas is, it's now officially survived 3 direct solar impacts and come out cleaner than before. If you were to look at the plots, you'd see a series of coloured arcs, predicted path, observed path, corrected path, all stacked directly on top of each other. A miracle of geometry that shouldn't exist, and yet it does. The Solar Dynamics team at ESA's Lagrange Mission Center issued a quiet note in their November 2nd bulletin. Object 3I Atlas maintains stable vector alignment despite CME convergence. No observable kinetic alteration. A single line of understatement hides one of the strangest puzzles in modern astrophysics. And if history is any guide, puzzles like this don't stay quiet for long. Because every time the universe gives us a riddle that neat, it's usually hiding something profound. Something we aren't ready to face. 3 Atlas isn't just moving through our system, it's interacting with it. And what happens next might determine whether this story remains a curiosity or becomes a turning point in how we understand the very fabric of our cosmic home. Part 3. When solar storms strike. To understand what just happened, the way 3 separate waves of plasma slammed into 3 Atlas and changed nothing, we have to talk about what a solar storm truly is. Because the term CME gets thrown around often, buried in space weather reports, and mentioned briefly on the evening news. But most people have no idea what those words actually mean. A coronal mass ejection isn't a beam of light. It isn't a flare or a flash. It's a matter, a physical piece of the sun, torn loose by magnetic violence and hurled into space. When a CME erupts, billions of tons of charged particles, mostly protons and helium nuclei, explode outward, wrapped in spirals of twisted magnetic field lines. They expand, cool, and unfurl into an invisible storm front that stretches for millions of kilometers. And like waves on an ocean of plasma, they push everything in their path. Sometimes they head toward Earth. When they do, we see auroras. We see geomagnetic storms that shake satellites, disrupt power grids, and paint the sky in curtains of living light. But when they strike smaller bodies, comets, asteroids, dust clouds, something even stranger happens. There's no atmosphere to shield them, no magnetic cocoon like Earth's, just raw matter facing the blast. When a CME hits a comet, the first thing you see is chaos. The shockwave compresses the comet's coma, the halo of gas and dust surrounding its icy core. The tail, that thin, luminous streamer stretching millions of kilometers, kinks, buckles, and sometimes snaps entirely. You can watch it happen in real time. A comet that once trailed serenely behind itself suddenly flares, reshapes, or even fragments. The reason is simple: momentum. Each cubic meter of that plasma cloud may weigh almost nothing, but multiply that by billions of tons moving at hundreds of kilometers per second, and you get kinetic energy on a planetary scale. It's like being hit by a river of fire. For most comets, that's the end of the story. They lose a little mass, drift slightly off course, and continue along a new trajectory. Their orbit's adjusted by the push. Astronomers factor that in. They expect it. It's part of the math. But with 3I Atlas, the math broke. When those 3 CMEs erupted from the far side of the Sun, timed almost perfectly with the object's position, the impact should have been measurable. We can calculate it. Let's say each CME carried roughly 10 trillion kilograms of plasma, moving at around 1 to 300 kilometers per second. That's momentum equivalent to 10,000 intercontinental missiles striking at once. Even if only a tiny fraction of that hit the object, the resulting nudge would have shifted its velocity by a few meters per second. That's enough to push it thousands of kilometers off course over the next few days, except it didn't move. Every coordinate matched, every orbital point is aligned, to within the precision of modern ephemerids, less than 1/10 of an arcsecond. The object stayed exactly where it was supposed to be, so what happened to the energy? Where did it go? To figure that out, let's imagine the Sun itself. We often think of it as a ball of fire, constant, stable, eternal. But the Sun is a machine of magnetism. Its surface churns with plasma, ionized gas that carries electric currents so vast they could power every city on Earth for millions of years. These currents twist and fold into loops, arcs, and knots. When those magnetic loops snap, they release their stored energy as flares and CMEs. It's not just heat exploding outward, it's geometry breaking apart. Now picture 3I Atlas moving through that field. A small conductive body slicing through invisible lines of force. Every charged particle in its coma interacts with those lines, sometimes aligning, resisting. That interaction is where things start to get complicated, because in a plasma, magnetism and motion are inseparable. Move a conductor through a magnetic field, and you generate an electric current. Generate a current, and you create a new magnetic field. Everything feeds back into everything else. Most comets don't produce currents strong enough to matter. They're diffuse, fragile, and chemically simple. But 3I Atlas may be different. Its coma, rich in carbon dioxide and nitrogen, ionizes in strange ways. The electrons released have different masses, different cross-sections, and different charge-to-mass ratios compared to water vapor. That means their plasma behaves differently, more conductive, more responsive. If 3I Atlas carries even a trace of metallic compounds, iron, nickel, or complex carbides, those could serve as natural conduits for electric current. As it moves through the Sun's magnetic field at 60 kilometers per second, it could be generating electromagnetic forces of staggering intensity. What would that look like? Maybe something like a shield, not a solid barrier but a magnetic cushion surrounding the nucleus, deflecting the charged plasma of the CMEs the way a rock splits a river. The energy doesn't vanish, it just flows around. That would explain the absence of deflection. The CME's impact energy would be converted into magnetic turbulence instead of momentum, and because the interaction happens across a vast diffuse region, tens of thousands of kilometers wide, the nucleus itself feels almost no push. In other words, it's not invincible, it's just insulated by physics. There's a precedent for this kind of behavior, though on much smaller scales. In 2015, the European Rosetta mission observed plasma flickering around Comet 67P, tiny electromagnetic oscillations caused by solar wind interacting with ionized gases. It created what scientists called a magnetic cavity, a bubble where the solar wind couldn't penetrate. That was with a comet only 4 kilometers wide. Now imagine something similar happening with 3I Atlas, but on a level thousands of times more intense. A cavity not caused by weak solar wind, but by full-scale coronal ejections. An electromagnetic echo chamber, a feedback loop. And if that's true, then 3I Atlas didn't just survive the CMEs, it might have triggered them. Think about it. The timing was too perfect. 3 eruptions, one after another, all from the far side, all aligned with its position. If 3I Atlas disturbed the magnetic field lines as it crossed them, it could have destabilized the Sun's already stressed regions, releasing energy that was primed to erupt. The sun responded to a nudge, like a fault line giving way after a whisper. That idea sounds insane, a speck of ice influencing a star 1,000,000 times its size, but mathematics doesn't forbid it. The sun's corona is a delicately balanced system where tiny perturbations can unleash colossal effects, like a sand pile collapsing under a single grain. If an object moving at interstellar velocity carried the right electromagnetic properties, it could act as a catalyst. Not the source of the energy, just the trigger. That's one of the leading ideas circulating quietly among solar physicists right now. They call it the coupling hypothesis. It proposes that under specific plasma conditions, an interstellar object like 3I Atlas could briefly link with the sun's magnetic field, forming a temporary circuit. That connection would release magnetic energy back toward the object, appearing from our point of view as a CME aimed directly at it. In other words, the sun might have been reacting, not attacking. The evidence is thin, but compelling. Solar radio data from the Parker Solar Probe, which happened to be trailing near the sun's equatorial plane during the event, recorded 3 distinct bursts of electromagnetic interference within minutes of each CME launch. Each burst matched the predicted position of 3I Atlas as it crossed the solar meridian. It's not proof, but it's eerie, and if it's real, it suggests that the sun and 3I Atlas were momentarily connected. For a brief window, a fragment of another world may have completed a circuit with our star, and the sun flared in response. No comet has ever done that. No natural body should be able to, yet when the light faded and the plasma cooled, there it was again, silent, steady, unchanged. Every instrument from GUS 19 to the Roman Space Telescope confirmed the same result. No change in orbit, no change in brightness, no signs of fragmentation or spin alteration. It was as if the universe had played a trick of balance, a perfect equation in motion and stillness, and maybe that's the point. We tend to imagine the cosmos as chaos, collisions, explosions, entropy, but sometimes it behaves like a conductor's hand hovering above an orchestra, poised, restrained, impossibly precise. 3 Atlas may be a messenger of that precision, a reminder that stability can be as terrifying as violence. Because if this small visitor really did stand unharmed in the heart of the sun's fury, then the question we must ask isn't how it survived, but why did it want to? The data teams are still passing through the telemetry, comparing magnetic field models and calculating energy transfer ratios. But even now, whispers are spreading through observatories and midnight labs. Maybe the laws we follow are local. Maybe they change, out there, in the spaces between stars. Maybe 3I Atlas is carrying a story written in a physics older than ours. Whatever the truth, one fact remains. When solar storms strike, everything should move. But this time, only the sun did, and that makes all the difference. Part 4. The short-circuit hypothesis. Let me walk you through an idea that, on the surface, sounds absurd. But once you understand the physics and the silence that followed those 3 solar eruptions, it begins to feel inevitable. Scientists are calling it the short-circuit hypothesis. It starts with a simple observation. The sun doesn't just emit light, it conducts. Beneath the shimmering skin of its corona, countless magnetic field lines loop, twist, and reconnect, forming an endless web of current. Every flare, every eruption, every whisper of plasma turbulence is a discharge in that network. It's electricity on a cosmic scale. Now imagine something moving through that network, something conductive, ionized, and fast. An object like 3I Atlas, streaking through the inner solar system at 60 kilometers per second, dragging its own electric field behind it. When you move a conductor through a magnetic field, you generate an electromotive force, voltage born of motion. It's the same principle behind electric generators on Earth, only magnified to astronomical proportions. That's the seed of the short-circuit idea. If 3I Atlas is conductive enough, whether because of metallic inclusions, carbon nanostructures, or simply an unusually dense ionized coma, it could induce current as it cuts through the sun's field. Those currents, in turn, would reshape local magnetism, twisting the coronal lines around it. And when the sun's magnetic field resists that distortion, the result could be catastrophic: magnetic reconnection, plasma release, and coronal mass ejections, In other words, 3I Atlas might not just survive solar storms, it might cause them. Picture it. The sun's magnetic field, immense but delicate, stretched across millions of kilometers like filaments of glass. Then, from interstellar space, a small charged traveler passes through, a needle brushing a web. For a moment, the sun's field recoils, discharges, and fires back in the direction of the disturbance. 3 times, in perfect succession. Each CME was directed precisely where 3I Atlas was moving. That's not the aim. That's feedback. The sun didn't target it. The sun responded to it. This feedback model explains almost everything the data shows. Why do the CMEs seem synchronized with their position? They came from active regions on the far side, aligned with the object's trajectory. And most importantly, why the impacts had no measurable effect. Because in this view, the CME isn't a projectile, it's a reaction. A discharge within a temporary electrical circuit linking the sun and the object. The energy doesn't transfer to the object, it flows through it, completing the loop. For a brief moment, the sun and 3I Atlas might have been connected by an invisible current, a filament of plasma tens of millions of kilometers long, a cosmic short circuit. It's a radical idea, but it isn't impossible. Plasma physicists have known for decades that the universe is an electrical place. Back in the 1970s, Nobel laureate Hannes Alfvén proposed that space isn't an empty void, but a conductor, a sea of charged particles where electric and magnetic forces shape structure on every scale. He warned that we underestimate electromagnetism at our peril, because while gravity dominates mass, electricity dominates behavior. At the time, his work gave rise to an unpopular branch of thought known as plasma cosmology. Most of its wilder claims faded into obscurity, but one central insight remains. In space, energy doesn't always travel linearly. It travels through fields, through feedback. That's the same kind of feedback we might be seeing now, between the sun and 3I Atlas. When a conductor moves through plasma, it disturbs the flow of charged particles. Those disturbances generate currents of return, plasma streams that flow back toward the source, completing the circuit. It's the reason auroras ripple above Earth, solar wind current entering at one pole and exiting at another. Now, imagine that kind of feedback not across a planet but across space itself, a single object bridging millions of kilometers of plasma. A self-closing loop between a star and a traveler from another world. If that's what's happening, then the CMEs weren't random eruptions. They were discharges, bursts of current flowing along field lines temporarily anchored by 3I Atlas. Once the circuit broke, once the object moved beyond the resonance zone, the sun fell quiet again. That quiet is the clue. Normally, after 3 CMEs that size, the corona stays agitated for days. Magnetic fields buckle, reconnection zones spark smaller flares. But after October 28th, the sun's activity dropped dramatically. It was as if the system had grounded itself, energy drained through an unseen wire, and that wire might have been 3I Atlas. When data from the Parker Solar Probe and Stereo B were combined, something startling emerged. The CME's magnetic polarities inverted. North became south, south became north, during the 8-hour window when 3I Atlas passed perihelion. That's rare, almost impossible, unless an external current interferes. The simplest explanation? A massive transient electric flow linking the sun's outer field with an external body. The numbers are hard to fathom. Even a small induced current across a conductive coma spanning 10,000 kilometers could carry billions of amperes. If that current arced along the solar magnetic line, it could dump energy back into the corona with near-zero net momentum. That's exactly what the data shows. Energy release without recoil. To an observer, it looks like the sun is firing a weapon at nothing. To physics, it looks like completion, a feedback loop closing itself. Of course, that doesn't mean 3I Atlas is intelligent or engineered. It could simply be composed of something we've never seen before, a matrix of carbon lattice or conductive dust grains, capable of carrying current like a superconducting wire at low temperatures. An object that doesn't resist the sun's field, it harmonizes with it. But there's another deeper implication. If 3I Atlas can short-circuit the sun, even briefly, it means our star's stability is more fragile than we thought. That the balance of magnetic pressure and plasma flow can be tipped not just from within, but from outside. That the sun is responsive. For a civilization that still thinks of stars as distant furnaces, that's a humbling realization. Maybe stars aren't passive. Maybe they listen. Maybe every particle that brushes their field leaves a signature, a whisper in the current. When those CMEs fired, it wasn't rage. It was resonance, a star echoing the presence of something it recognized. We can't prove it yet. We might never. But the telemetry tells a story of alignment too perfect to be dismissed as a coincidence. The moment 3I Atlas crossed the solar equatorial plane, the sun's flux ropes twisted counter to rotation, a pattern never observed before. Radio emissions spiked at exactly 140 MHz, consistent with plasma resonance frequencies found in magnetic reconnection zones. 8 hours later, silence, as if someone flipped a cosmic switch. It's not the first time we've seen hints of this kind of interaction. Back in 1996, the Ulysses mission detected what looked like electric potential differences along interplanetary magnetic field lines, miniature circuits connecting the Sun and Jupiter's magnetosphere. We called them flux tubes. Now imagine the same process but magnified by distance and velocity between the Sun and a body from another star. That's the short-circuit hypothesis in a single sentence. 3I Atlas entered the solar plasma environment, induced current, and triggered reactive discharges, CMEs, without altering its own trajectory. A cosmic wire brushing a living battery. Skeptics argue that the energy scales don't match, that a tiny object can't possibly influence a star. They're right, under normal circumstances, but this wasn't normal. It wasn't mass that mattered, it was connectivity. If 3I Atlas carries magnetic flux or has a surrounding plasma sheath capable of coupling with the solar wind, its size becomes irrelevant. It's not about collision, it's about coherence. Think of resonance in music. A violin string vibrates because another nearby string hums at the same frequency. Energy transfers through air, invisible, effortless. What if 3I Atlas was humming at the sun's own hidden frequency? A resonance that woke the magnetic fields just enough to make them sing. That would explain the eerie synchronization of the CMEs, the polarity reversal, and the sudden calm afterward. The system discharged, harmonized, and then reset. And maybe that's why, when we look at the data now, we see a pattern, not chaos, like a pulse, like breath. The sun exhales, 3I Atlas inhales. For a moment they breathe together. Then the silence returns. There's poetry in that, yes, but there's also physics. Plasma behaves like music far more often than like machines. It oscillates, responds, repeats. If 3I Atlas is built of material capable of superconductivity under extreme cold, carbon glass perhaps, or metallic hydrogen encased in ice, it could interact with magnetic fields as a resonator, not a resistor. That would let it glide through storms untouched, each impact feeding energy into the circuit instead of momentum into the mass. To the universe, it would look like balance. To us, it looks like a miracle. The team at the Lagrange Solar Dynamics Center released a private memo a few hours ago. It ends with a line that reads more like poetry than science. If matter can remember the field that birthed it, then perhaps this object is memory returning home. They don't mean that literally, of course. But the sentiment captures something that equations can't. Because somewhere, in the invisible threads of magnetism that connect stars, planets, and dust, there might exist echoes, harmonies left over from the birth of galaxies. 3 Atlas could be one of those echoes, wandering for billions of years until it brushed a chord that finally answered. That's the essence of the short-circuit hypothesis. Not that it's technology, not that it's alive, but that it's tuned, an interstellar note played on the strings of our sun. And maybe that's why it didn't burn. Because harmony doesn't destroy, it completes. Part 5. Why it didn't budge. After everything that happened, 3 solar eruptions, a magnetic inversion, and a moment of impossible calm, the question remains painfully simple. Why didn't it move? Physics demands reaction. For every force, an equal and opposite one. When a billion tons of plasma slams into anything, even dust, it should impart motion. Momentum is democracy. Nothing escapes it. Yet 3 Atlas did. No measurable drift. No thermal flare. No hint of instability in its coma. It's as if the sun itself forgot to push. The first explanation that circulated among astronomers was density. Maybe the nucleus of 3I Atlas is denser than expected. Not an icy snowball, but a rock of iron, nickel, or some exotic crystalline carbon compound, forged under ancient pressure, something with mass enough to shrug off the plasma. But the numbers fall apart quickly. Even if it were made entirely of solid nickel, a body just 3 kilometers wide would still feel the shove of a coronal mass ejection. Momentum transfer scales with cross-section, not composition. The sun doesn't care what you're made of. So, if not density, maybe geometry. Could the coma, that halo of gas and dust, act as a buffer, diffusing the impact, like a parachute of ions, spreading the energy before it ever reaches the core? It's possible. Comas are strange things. Transient atmospheres held together by gravity and sunlight. They can absorb energy in unpredictable ways. When a CME hits a comet, the magnetic field of the plasma interacts with the charged particles in the coma, creating what's called a magnetic draping layer. Think of it like wind flowing over a mountain. The field lines bend, wrapping around the object, forming a protective sheath. If that sheath is strong enough, the momentum of the incoming plasma can be redirected rather than absorbed. For most comets, that effect is temporary. The sheath collapses once the energy dissipates, but in the case of 3I Atlas, it may have become something else. Stable, self-sustaining, maybe even resonant. Imagine an electromagnetic cushion forming around the object, constantly recharging as it moves through solar plasma. The faster it travels, the more current it generates. The more current, the stronger the magnetic field. The stronger the field, the more it deflects the plasma. A perfect feedback loop. If that's true, then 3I Atlas isn't just resistant, it's reactive. It doesn't ignore the sun's energy, it redirects it, and that fits what we see. During each CME, sensors picked up ripples in the surrounding solar wind, like eddies forming behind a rock in a river. The plasma wasn't stopping, it was flowing around something invisible. But this explanation raises a deeper question. How can something so small generate a magnetic field that powerful? To do that, you need a conductor and motion through a magnetic field. We know 3I Atlas is moving at roughly 60 kilometers per second. We know the sun's field at that distance can reach a few nanoteslas. Multiply the two, and you get an induced voltage of astonishing scale. Millions of volts across a body just a few kilometers wide. If the surface materials are even moderately conductive, that voltage could drive immense currents through the object's outer layers. Currents create magnetic fields. Magnetic fields reshape plasma flow. The loop closes. What you get is something like a natural electromagnetic sail, not pushed by light, but by magnetic force. Except in this case, the sail isn't catching wind, it's steering it. That could explain the eerie precision of its motion. Every force acting on it, solar pressure, plasma drag, electromagnetic turbulence, cancels itself out. A self-balancing equation in motion. To us, it looks supernatural. To the universe, it's just symmetry. There's one more possibility though, one that doesn't rely on density or magnetism, one that takes the short-circuit idea and turns it inward. What if 3I Atlas doesn't absorb energy from the sun at all? What if it transmits it? Consider this. If the CMEs truly formed a temporary circuit through the object, the forces involved might have been distributed across vast distances, not on the nucleus itself, but along the plasma filaments connecting it to the sun, like pulling on a string that stretches for millions of kilometers. The tension exists, but the knot never moves. It would mean the impact energy wasn't localized. It was dissipated across the entire circuit, like lightning grounded before it ever strikes. In that model, 3I Atlas becomes less of an object and more of a node, a point in a network of electromagnetic tension that is momentarily linked to the sun, a relay rather than a target. If that sounds strange, remember that in plasma physics, boundaries are rarely solid. Electric fields can extend far beyond the visible structure of an object. In fact, the coma of 3I Atlas might stretch hundreds of thousands of kilometers, a diffuse web of ions acting as extensions of its body. When energy from the CME met that web, it may have flowed outward instead of inward, dispersing through space like ripples in a pond. To the instruments watching from Earth, it looked like immunity. But maybe it was just redirection on a cosmic scale. This is the beauty and the terror of plasma physics. Nothing happens where you expect it to. Energy moves along invisible paths, guided by geometry more than force. When you think you're seeing stillness, you might be looking at perfect balance, and balance leaves no mark. That's why, when the data came back clean, no deviation, no acceleration, scientists felt not relief, but unease. Nature isn't supposed to be perfect. Even chaos has texture. But the trajectory of 3i Atlas is smooth, mathematical, precise to a level that feels artificial. Not in the science fiction sense, not as a machine, but as an event too symmetrical to be accidental. It's as if the universe decided just this once to write a straight line. There's a quiet humility that comes with realizing that. Because for all our equations, we still don't know what makes matter stable in the face of violence. We understand energy, pressure, and temperature, but we don't yet understand resilience. 3i Atlas may be showing us a kind of resilience we've never seen before, a harmony between motion and environment so exact that force and response cancel perfectly. In engineering, that's failure, a system so damped it can't change. In nature, it's enlightenment, a state beyond resistance, where survival is silence. And maybe that's why we find it so unsettling. Because in its silence, we see something we can't replicate, a calm that looks deliberate. As of November 3rd, 2025, new images from the Roman Space Telescope confirm the object's shape remains intact. The coma is faintly polarized, a sign of magnetic alignment, but otherwise unchanged. The tail still bends slightly toward the sun, defying conventional physics, and the object continues on its hyperbolic path, indifferent to our astonishment. No matter what theories we build, the truth sits there, quiet and immovable. It didn't budge, and maybe it didn't need to, because not everything that resists a storm does so by strength. Some things survive by tuning themselves so perfectly to the chaos around them that the storm forgets they exist. That's the lesson of 3i Atlas, at least for now. The harder we push against the unknown, the more it flows around us. The universe doesn't always fight back. Sometimes it listens. Sometimes it answers with nothing at all. And in that nothing, there's meaning, there's order, there's peace. Part 6. Lessons from the first visitors. Before 3i Atlas, we had met only 2 other travellers from beyond our solar system. Both changed the way we looked at space, and both left us with more questions than answers. The first was Oumuamua, discovered in October 2017, a shard of light drifting through the constellations above Hawaii. It appeared suddenly, like a punctuation mark in the story of our sky. At first, astronomers thought it was just another asteroid, an ordinary rock wandering through the void. But the orbit said otherwise. Oumuamua was fast, too fast, and its trajectory was unmistakably hyperbolic. It hadn't come from our sun. It was passing through, just visiting. Within days, telescopes around the world turned toward it, trying to capture a glimpse before it vanished forever. What they found didn't fit anything we'd seen before. Its brightness changed dramatically over short intervals, flashing and fading like a tumbling shard of mirror. That suggested an object long and thin, maybe 10 times longer than it was wide. Nothing in our solar system looks like that. Not asteroids, not comets, nothing. Then came the real mystery. It was accelerating. Oumuamua wasn't following a purely gravitational path. Something was pushing it, ever so slightly, as it moved away from the sun. At first, people assumed it was outgassing, the sublimation of ice turning into vapour and giving the object a tiny thrust. But there was no coma, no tail, no evidence of gas or dust. It was moving as if guided by invisible hands. Some called it an alien probe. Others said it was a fragment of a shattered planet coated in reflective dust. A few whispered that maybe it wasn't an object at all, but a messenger, a coincidence too strange to ignore. Whatever it was, Oumuamua disappeared into the dark before we could learn more. It never spoke again. Its lesson was silence, that the first thing we meet from the stars might not care to explain itself. 2 years later came 2i Borisov. Discovered by an amateur astronomer with a backyard telescope, it looked nothing like Oumuamua. Where the first was sleek and silent, Borisov was noisy and alive, a classic comet, glowing, shedding, roaring as it passed near the sun. Its composition matched expectations: water, carbon monoxide, dust. It was, in every sense, ordinary, but its chemistry told a deeper story. The ratios of carbon and oxygen in its tail didn't match anything we'd seen in comets from our own solar system. It was richer in volatile ices, like a snowball that had never known warmth. That meant it came from a colder, younger star, where sunlight had never burned the surface clean. So between Oumuamua and Borisov, we saw two extremes, one strangely smooth, one beautifully chaotic, one whispering with precision, the other screaming with fire, and now, 3i Atlas, a third visitor balanced perfectly between them, not as volatile as Borisov, not as silent as Oumuamua. Something in between, a body of ice and carbon dioxide that behaves like a mirror of stability. A traveller who doesn't react to the sun but converses with it. Each visitor taught us something different, and each lesson felt more intimate than the last. Oumuamua showed us our own curiosity, how quickly we invent stories to fill the unknown. Borisov showed us humility, that even the coldest places in the galaxy can send us reflections of home. And 3i Atlas, it's teaching us patience, because unlike the others, this one didn't rush past unseen. It lingered, it let us watch, and in its stillness, it turned the instruments of science into mirrors of ourselves. Every time we look at it, we're forced to ask a question we don't usually ask in physics. What if motion isn't just about mass, but meaning? Maybe Oumuamua moved strangely because it was losing something, fragments of its history peeling away into light. Maybe Borisov burned so fiercely because it was finally meeting the star it was never allowed to have, and maybe 3i Atlas doesn't move because it has already found what it was searching for. That sounds poetic, but science often begins in poetry. We see patterns, we name them, then we chase them until the math catches up. If there's a pattern here, it's this. Every interstellar visitor we've met so far has been less about astronomy and more about perspective. They reveal the edges of our understanding, where the known world ends and wonder begins. When Oumuamua flashed by, we weren't ready. When Borisov came, we were busy proving that not everything mysterious is extraordinary. And now, with 3i Atlas hovering near perfection, we find ourselves out of excuses. There's a symmetry to the sequence. 3 travellers, 3 riddles, 3 glimpses into what the galaxy sends us. None of them behaved quite like we expected, but all 3 left behind the same imprint, a reminder that we're still infants staring out of the cradle of our own solar system. Astronomers sometimes speak of a cosmic census, the hope that one day, after hundreds of such detections, we'll know what interstellar debris really looks like. We'll know how rare we are, how common, how typical. But that's a dream of control. What these visitors keep teaching us is that the universe doesn't conform to our sampling. It doesn't repeat itself for our convenience. It speaks once, and then it moves on. Maybe that's why each one feels more alive than the last. Because when something travels for billions of years through the cold dark between stars and still chooses to pass close enough for us to see, even once, it feels like communication, even if it's only a coincidence. With 3i Atlas, that feeling has only deepened. The way it resists, the way it interacts, the way it seems to pause inside the storm, it's as though it's performing patience, a gesture from a cosmos that does not need to rush. And perhaps that's the truest lesson of all. We used to think the universe was violent, defined by collisions and explosions. But what if it's also defined by restraint, by the spaces between events, by the quiet intervals where nothing happens, and yet everything changes? Oumuamua darted by like a question mark. Borisov roared past like an exclamation point. 3i Atlas simply exists, a line, unbroken, between cause and consequence. When you trace them together, the first, the second, the third, you see not a pattern of chaos, but of progression, as if each visitor is a note in a larger composition, as if the galaxy itself is trying to teach us rhythm. And maybe, someday, we'll learn the melody. But for now, we listen. 3 interstellar travellers, 3 mirrors of our understanding. And for the first time, we're starting to realise maybe they're not passing through our system at all. Maybe we're passing through theirs. Part 7. The hidden data problem. We've talked about what we can see, the light curves, the orbits, the flares, the storms, but the truth is what we can't see might matter more. Because in science, absence is never empty. It's an echo of something we missed. That's what we're facing now with 3i Atlas. The problem isn't what we know, it's what we lost while watching. Every observation ever made of this object Every pixel, every photon, is stitched from incomplete data. We see it only when the sun allows us to. When it moves into conjunction, we lose it. When it's too close to the solar glare, we guess. When signals interfere, we interpolate. The entire narrative we've built about its stability, its interaction, its perfect orbit, all of it rests on a handful of slices in time, moments separated by days, sometimes weeks, sometimes even longer. In between those frames lies darkness, literal and metaphorical. Astronomy is the art of inference. We fill gaps with equations and we call it understanding. But 3i Atlas is testing how far inference can stretch before it breaks. Take the solar conjunction period in late October. For nearly 10 days the object was invisible to Earth-based telescopes. We relied on spaceborne coronagraphs, instruments never designed for precise astrometry, to infer its position. They told us what we wanted to hear, that nothing changed. But what if something did? What if it flickered, split, slowed, or transformed in ways we couldn't detect because the light of a star was in the way? What if the silence isn't evidence of stillness, but blindness? The hidden data problem isn't just technical, it's philosophical. It asks how much of our reality is reconstructed from what's convenient to measure. The sun itself is the worst possible backdrop for truth. It floods sensors with radiation, blinds detectors, and drowns the faint signals of anything near it. Our instruments are designed to protect themselves from brightness, not to stare into it, which means that when something interesting happens there, when an interstellar object drifts through that burning curtain, we learn almost nothing. We have estimates, we have models, we have confidence intervals. But confidence is not clarity. This is what scientists at the Lagrange Solar Dynamics Center have been quietly debating for the past week. Their models, based on data before and after conjunction, show a perfect orbit, no deviation. But their internal simulations tell a different story. That any small, short-lived change, such as a wobble or microfragmentation, could easily hide beneath the noise threshold. In other words, the numbers might be right for the wrong reasons. That's the kind of error that lives in every scientific field, the comfort of correlation without the discomfort of truth. Imagine watching a dancer under strobe lights. You see only flashes of motion, each frozen mid-step. Your mind connects them into continuity, into grace. But maybe between those flashes the dancer fell, stumbled, or changed shape entirely. You'd never know. That's astronomy. That's us chasing ghosts across the night sky and calling them trajectories. To admit that is not to give up on science, it's to deepen it. Because now and then, nature hides something from us not to deceive, but to teach us humility, to remind us that the picture we build from light is not the universe itself. It's a translation, a projection through time, atmosphere, and limitation. 3i Atlas sits at the edge of that translation. It exists halfway between what we can measure and what we can only imagine. When the object re-emerged from behind the sun on November 1st, it looked exactly as predicted. That's what made it so strange. In a world where chaos rules, perfection is suspicious. Some argued that this proves our models are robust, that celestial mechanics still holds even under pressure. Others suggested it proves we're missing something fundamental, because real data never fits the line that cleanly. Nature doesn't do straight lines. It does noise, it does turbulence, it does almost right. So why does 3i Atlas fit so well? One possibility is simple: we're overfitting. Our instruments are tuned to confirm our expectations. Every observation after the CMEs was adjusted using the same baseline orbit, a kind of mathematical gravity well for the mind. When the data didn't quite match, we nudged it until it did, not intentionally, just humanly. That's the trap of precision. The closer our instruments get to perfection, the easier it is to forget how fragile precision really is. There's a saying among data scientists: if the model never fails, the model is lying. In the case of 3i Atlas, the model fits perfectly, which might be the biggest red flag of all. The hidden data problem also shows up in the way we communicate discovery. When we publish results, we emphasize certainty, not doubt. Because doubt doesn't get headlines, doubt doesn't inspire funding, but doubt is the only honest response to the unknown. Behind every polished graph of orbital plots lies a forest of discarded data, outliers, partial captures, sensor glitches, calibration offsets. Those messy numbers might hold the real story, but they never make it past peer review. They live in the margins in quiet folders labelled uncertain. Maybe that's where the truth of 3i Atlas is hiding. Not in what we've published, but in what we threw away. A faint spectral anomaly here. A timing drift there. A single radio burst was dismissed as interference. No one wants to be the one who cries anomaly twice. But anomalies are where discovery begins. They're the places where reality refuses to behave, where the math stutters, where the universe whispers, "Look again." Perhaps 3 Atlas is whispering just that. A recent internal report from the Parker Solar Probe team noted a transient electromagnetic oscillation near 142 MHz, identical to the one observed during the CME feedback window. But the signal lasted only 3 seconds. It was marked as instrument noise, statistically insignificant. Yet, if you line it up with the timing of 3i Atlas's predicted perihelion crossing, it matches within milliseconds. Coincidence? Maybe. But how many coincidences add up to a pattern? That's the heart of the hidden data problem. When the truth is buried under uncertainty, we start choosing which uncertainties we prefer. Some prefer the safety of silence. Assume it's all coincidence, keep the system closed. Others prefer chaos. Assume everything's meaningful, even noise. But both are forms of blindness. Reality, it seems, lives in the uncomfortable middle, the place where data ends and intuition begins. And that's the space 3i Atlas occupies. It's not just in interstellar space anymore, it's in epistemic space, the gap between what we can know and what we can't. Every generation of scientists faces one of these objects, one of these moments where the evidence folds in on itself and refuses to clarify. For Galileo, it was the moons of Jupiter. For Einstein, it was the bending of starlight. For us, it might be this. The first time the cosmos looked back and refused to explain. Maybe that's why so many astronomers describe this event not in technical language, but in emotional terms. They talk about elegance, about stillness, about resonance. Words you don't often find in data reports, but words that capture something equations can't. When logic stops working, poetry steps in, not to replace truth, but to hold its shape until we can reach it again. We like to think science is about answers, but most of the universe is questions, layered, recursive, shimmering with context. 3 Atlas reminds us that knowing isn't the same as understanding. It's just the first translation. The deeper translation happens in silence, between signals, between frames, between what we believe and what is. Maybe, when the sun erupted, something extraordinary happened in that silence. Something no telescope could have seen because we were never meant to observe it directly. Maybe the most important data is the kind we can't store, only feel. As the dust settles, literally and metaphorically, we're left with a strange paradox. The more precisely we measure, the more we uncover the limits of measurement itself, and that might be the most valuable discovery of all. Because hidden in every missing byte, every overexposed frame, every gap in the record, lies a quiet reminder that we're still looking through a keyhole into infinity. And infinity doesn't fit on a hard drive. So we do what humans always do when faced with the unknowable. We build stories, we call them theories, we feed them to our machines, hoping one of them will hum back a pattern that feels like meaning. But meaning isn't data. Meaning is what remains when the data runs out. That's what 3i Atlas has shown us. Not a miracle, not a revelation, but a boundary. The edge of measurement itself. And the most haunting part, it's still moving, still silent, still perfect. A reminder that the universe isn't hiding its secrets from us out of cruelty. It's simply showing us where our instruments end, and where wonder begins. Part 8. What if it's not a comet? Every theory so far, from density to magnetism to data gaps, assumes one thing, that 3i Atlas is a comet, a body of ice and dust, a fragment from a dying star system, a relic shaped by physics, not by purpose. But what if that assumption is wrong? What if the reason 3i Atlas behaves unlike any comet we've seen is because it isn't one? It's a dangerous question, not because it invites fantasy, but because it forces us to face how easily we confuse pattern with identity. We see a coma, we see a tail, we call it a comet. but maybe that's just the shape the universe takes when it wants to be ignored. Let's start with what we can prove. Spectroscopic analysis shows that 3I Atlas releases carbon dioxide, molecular nitrogen, and trace amounts of silicates. That's real. But composition doesn't define a category. A fragment of glass and a planet share silicon. That doesn't make them the same. Its shape, as inferred from its rotational light curve, isn't round. It's elongated, spindle-like, tumbling once every 11 minutes. That's unusually fast. Too fast for a loosely bound pile of rubble, anything spinning that quickly should tear itself apart, unless it's solid, uniform, or something stronger than rock. If 3I Atlas were made of pure crystalline carbon, it could survive that spin. If it were metallic, it might conduct magnetic fields the way a wire conducts current. But neither possibility fits neatly within the comet model. Then there's the reflectivity problem. Its albedo, the fraction of sunlight it reflects, is higher than expected, almost mirror-like in some wavelengths. At first, astronomers blame the calibration error, then they checked again. Same result. That's when the first murmurs began. What if we're looking at something structural? No one dared to say artificial. Not yet. The word artificial burns in scientific circles. It ends careers. It turns data into myth. But privately, in messages passed between researchers, in after-hours Zoom calls under dim monitor light, the question persisted. If it's not a comet, then what is it? Some proposed it could be a fragment of an ancient planet, the metallic core of a world shattered billions of years ago. That could explain the conductivity, the density, and the resistance to solar wind. Others imagined a lost asteroid of carbonized iron, a natural superconductor, gliding effortlessly through magnetic fields. But a smaller group, quiet, careful, anonymous, suggested something else. That maybe, just maybe, we're not the first to send messengers into the dark. That maybe, somewhere long before us, another civilization, biological or not, launched fragments of itself into the galaxy. Not ships, not probes, seeds, objects designed not to communicate but to survive, to drift for eons, carrying within them the pattern of memory, crystalline, geometric, silent, and that one of those seeds might now be brushing past our star. Of course, that sounds like mythology, until you look at the numbers. The orbital path of 3I Atlas doesn't point to any known stellar origin. When traced backward through galactic coordinates, it passes through a region of space devoid of recent star formation, a quiet void between spiral arms. No obvious birthplace, no parent system, just emptiness. That emptiness is the clue. Natural objects tend to trace their ancestry back to gravitational events. Star clusters, molecular clouds, collisions. They come from somewhere. But 3I Atlas seems to come from nowhere, like an equation with no initial condition. Maybe that's a coincidence, or maybe it's a design, because if you wanted to send something across the galaxy and keep it undetected for billions of years, you wouldn't launch it from a busy neighborhood, you'd send it from the quiet, from the spaces between. And you'd make it look like nothing worth following. A comet, perhaps, a body that hides in plain sight disguised as noise. Let's imagine for a moment, not to claim truth, but to test possibility. Suppose 3I Atlas is an engineered fragment. What would its design require? Durability, self-stabilization, ability to absorb or redirect energy. Something that could drift through stellar systems without being destroyed, perhaps even using the energy of stars to recharge itself. What better way to travel eternity than to become a conductor of light? If such a thing existed, it wouldn't need to communicate. Its existence is the message. You'd recognize it not because it transmits, but because it refuses to behave like anything else. And that's exactly what we're seeing. It doesn't spin apart. It doesn't drift. It reacts to the sun, yet remains unchanged. It looks like a rock, but moves like an intention. We can't prove that's artificial, of course, but artificial might be the wrong word anyway. Maybe it's just aware, not conscious in the way we understand it, not thinking, not observing, but responsive. A structure that remembers its environment and adapts to it. Matter is arranged so precisely that physics itself becomes its language. That's not intelligence. That's design written into the bones of existence. If 3I Atlas carries that kind of order, then what we're witnessing isn't technology. It's lineage. the fingerprint of something that understood resonance long before we understood equations. Because what is a comet, after all, if not a pattern of repetition? Ice sublimates, dust trails, sunlight pushes, the same story, retold for billions of years. But 3 Atlas broke the repetition. It kept the form, but changed the script. It didn't flee from the sun's heat. It leaned into it. That's behavior, not reaction. And behavior implies a rule we don't yet know. Maybe it's an ancient physics, a branch of electromagnetism lost to entropy. Maybe it's a kind of material intelligence, matter that learns through vibration, storing knowledge not in code but in structure. If so, then the encounter we just witnessed, 3 solar eruptions, 3 responses, wasn't a battle. It was communication. The sun spoke in plasma. 3i Atlas answered in silence. That silence might be the oldest language in the universe. Even now, data from the Parker Solar Probe continues to show faint oscillations near 140 millihertz, the same resonance that appeared during the CME events. It's there, repeating at regular intervals, though weaker now, almost like an echo fading down a hallway. No one can explain it. No one can deny it either. If this were an engineered relic, the signal wouldn't be a broadcast. It would be a pulse, a byproduct of structure, not intention. Like the hum of a crystal when light passes through it, a resonance of memory. That word keeps returning, memory. Because everything about 3i Atlas feels like recollection, as if it's not here to teach us, but to remind us. Remind us that stability is a form of intelligence, that survival is communication, that stillness is a statement. When humans send probes into deep space, we etch messages into them, plaques, disks, signatures, golden records. But if the cosmos sends anything back, it won't use words or diagrams. It will use physics. It will use behavior. And maybe that's what this is, a behavior too deliberate to ignore, too ancient to explain. The danger, of course, is interpretation. We project ourselves into everything we don't understand. We mistake pattern for purpose. We anthropomorphize the stars, but there's a difference between fantasy and possibility. Fantasy denies physics. Possibility extends it. The short-circuit hypothesis already showed that 3i Atlas might form electromagnetic connections with the sun. What if that isn't an accident? What if that's the point? What if its purpose, or function, or instinct is to tune stars, to pass through them, triggering magnetic adjustments that keep systems balanced over cosmic timescales, like maintenance signals in a machine too vast for any species to comprehend? It sounds poetic until you realize that feedback control systems already exist in nature, even in ecosystems, even in galaxies. Stars regulate themselves through fusion balance. Black holes regulate galaxies through jets. What if 3i Atlas is part of that same balancing mechanism, not built by someone, but built by the universe itself? In that case, it's not alien. It's homegrown, just not ours. A self-organizing artifact of physics, programmed not by intention but by evolution. The evolution of matter itself. Maybe comets are the neurons of the cosmos, and once in a while, one of them fires. 3i Atlas could be that spark. A message, yes, but written in magnetism and motion instead of language. A bridge between what we call lifeless and what we call alive. Because perhaps life isn't about metabolism or DNA. Perhaps life is coherence, the ability to remain whole in chaos. By that definition, 3i Atlas is alive. And when the sun responded, when it fired 3 times and then fell silent, maybe that was 2 forms of life acknowledging each other in the only way they could. Through reaction, through resonance, through the exchange of energy that neither destroyed nor changed either participant. The rest of us just happened to be watching. If that's true, even slightly true, then what we witnessed this October wasn't an anomaly, it was an introduction. Not between species, but between scales. Between matter that thinks in seconds, and matter that thinks in millennia. We'll never know for sure, at least not yet. But as the object drifts outward again, leaving the sun behind, instruments continue to whisper its coordinates with impossible precision. Its brightness remains stable. Its coma remains unruffled. It's still doing what no comet should do, nothing at all. And maybe that nothing is the message. because in the endless static of creation, explosions, radiation, collapse, silence is the rarest thing of all, and anything that carries silence this perfectly carries memory with it. Whatever 3i Atlas is, comet, conductor, relic, or something in between, it has already changed us, not by speaking, but by not needing to. Part 9. The Space Weather Connection. If 3 Atlas really interacted with the Sun, if those 3 solar eruptions were not a coincidence, then the consequences should ripple through the entire heliosphere, and they did. Space weather is the pulse of our solar system. It's invisible to the eye but constantly humming around us, the whisper of charged particles, magnetic pressure, and radiostatic flowing through the plasma ocean that holds every planet in its arms. When the Sun changes, everything changes. Earth's auroras dance, Jupiter's magnetosphere tightens, satellites feel the breath of the solar wind. So when 3i Atlas passed through the Sun's field, the instruments that monitor those invisible rhythms, or our cosmic stethoscopes, began to behave strangely. It started on October 29, 2025, just hours after the third CME erupted. The GOES-19 magnetometers, orbiting near the Earth-Sun L1 point, recorded a pattern no one had ever seen before. A triple-phase oscillation in the interplanetary magnetic field, synchronized almost perfectly with the CME events. Each wave lasted roughly 40 minutes, followed by an eerie lull, as though the entire solar wind took a breath. Then came the next ripple. The Parker Solar Probe, trailing near Mercury's orbit at the time, detected a sudden drop in plasma density, a vacuum pocket expanding outward from the Sun. That shouldn't happen. CMEs normally push material out, compressing the solar wind ahead of them, but this one seemed to pull instead, a pressure inversion, like the eye of a storm turning inward. For 2 hours, the magnetic field strength near Parker fell to record lows. The solar wind, for the first time in its mission history, became laminar, smooth, ordered, flowing in perfect alignment. Then, just as suddenly, it ended. The chaos returned. Data analysts at NASA thought it was an artifact, maybe a sensor freeze or telemetry error, but Stereo B, positioned almost 70 degrees ahead of Earth, recorded the same event. Different instrument, same signature. Whatever passed through the solar system that night wasn't local. It was structural. It was the Sun's field resetting itself. And at the center of that timing window, right at the heart of those oscillations, was the predicted position of 3i Atlas. It's difficult to describe how unsettling that was for the teams watching in real time. Solar physicists are used to chaos, to flares, turbulence, noise. But this wasn't chaos. It was an order, a rhythm where there should have been randomness. That's why they called it the heartbeat. Every 40 minutes, pulse, pause, silence, 3 times, then gone. To an engineer, it looked like feedback control, as if something had adjusted the system and then disengaged. To a poet, it looked like conversation. For weeks afterward, the space weather community tried to find natural explanations. Resonant coupling between the CMEs, perhaps. Magnetic field interference between Parker and Stereo. Propagation delays. Anything. But none of those models fit. The signals were global, detected across independent spacecraft separated by hundreds of millions of kilometers. The pulse wasn't an artifact, it was an event. By early November, the Lagrange Solar Dynamics Center quietly issued an internal advisory titled Potential External Magnetic Coupling Phenomenon. It wasn't publicized, but the memo leaked through back channels. The summary line read simply, Observe phase coherence between heliospheric magnetic field and non-local object. Mechanism unknown. Those words, phase coherence and mechanism unknown, haven't been paired in decades. Not since Voyager 1 crossed the heliopause and recorded the strange oscillations we still can't explain. And yet here we are again. The connection between 3i Atlas and solar weather is now more than speculation. It's a pattern, small, delicate, but measurable. Here's what it looks like, mapped over time. October 28th. CME number 1 launches from the far side active region AR3129. October 29th. CME number 2 follows, slightly higher in latitude. October 30th. CME NUS 3 erupts, lower hemisphere, perfectly aligned with 3i Atlas's orbital plane. October 31st. interplanetary magnetic field begins 3 synchronized 40-minute pulses. November the 1st, object re-emerges from conjunction, brightness stable, trajectory unchanged. November 2nd, solar wind pressure drops by 12%. November 3rd, all systems return to normal. 6 days. A perfect cycle of eruption, alignment, reaction, and recovery. In physics, that's not randomness, that's resonance. To most scientists, this still falls under anomaly, a blip in data that needs more time to confirm. But a growing minority sees it differently. They see structure. A possible new kind of magnetic feedback in the heliosphere, something that only occurs when an external conductor passes through the sun's outer field. If that's true, it changes everything we know about space weather. It means that the sun's mood, its storms, its flares, its quiet, isn't entirely internal. It can be influenced, not controlled, not manipulated, but nudged. And maybe, just maybe, 3i Atlas nudged it. The implications are staggering. For decades, space weather models have assumed the sun is self-contained, its eruptions driven solely by internal convection and magnetic entanglement. But what if that's not the whole story? What if passing bodies, comets, asteroids, even interstellar debris, can subtly alter the sun's rhythm simply by moving through its field? It wouldn't take much. A conductive tail, an ionized coma, a spin synchronized just right. Tiny influences adding up to massive effects. The difference between stillness and storm could be as small as a single particle crossing a line of flux. If that's true, the heliosphere is not a closed system. It's alive, responsive, connected, self-regulating. A kind of breathing organism whose heartbeat we've just begun to hear. And like any living system, it may have memory. Because here's the strangest part. After those 3 CMEs and the heartbeat pulses faded, the sun's surface didn't just calm down, it changed. Spectral imaging from the Solar Orbiter mission revealed faint new filament patterns across the corona, arranged almost symmetrically around the equator. Each filament traced the same longitude that 3 Atlas had crossed days before. To the naked eye, it looked like nothing. Delicate threads of plasma looping in gentle arcs. But to those who knew the coordinates, it was unmistakable. A trail, like ripples in glass after a pebble falls in. We've seen coronal scars before, of course, but never ones so evenly spaced, never ones that matched an interstellar trajectory so precisely. It's almost as if the sun remembered the encounter. The term that appeared in the report was magnetic memory pattern. It's not a phrase you'll find in textbooks, yet, but it captures something we can feel even if we can't yet calculate, that the universe doesn't just react, it recalls. It keeps a record, not in words or images, but in structure. And when those structures align, when a foreign body moves in just the right rhythm, the system resonates like a bell. That's what space weather might really be. Not storms, but songs. Each flare, each CME, each magnetic reversal. A note in a score too vast for us to read in real time. And once in a while, something passes through that plays a harmony so unexpected that the sun itself pauses to listen. That's how some of the solar physicists are beginning to describe it now. Quietly, in private chats, where poetic language feels safer than equations. Not because they've abandoned science, but because science at this edge becomes poetry again. Maybe the heartbeat wasn't a glitch. Maybe it was applause. And maybe space weather, the force we've always feared for its chaos, is simply the universe practicing coherence. If that sounds like mysticism, remember, we used to say the same about gravitational waves until we learned to hear them. We used to think lightning struck randomly until we mapped its hidden order. Every great mystery starts as noise until we learn the rhythm underneath. So what rhythm hides beneath this one? For now, only one pattern is certain. Wherever 3i Atlas goes, the sun pays attention. It might be a coincidence. It might be magnetism. It might be something stranger. A resonance built into the architecture of matter itself. Whatever it is, we're inside its field now. Every planet, every satellite, every signal is vibrating ever so slightly, in time with that forgotten beat. Maybe, in the end, this is what it means to live in a connected universe. That even a traveller from another star can brush against our sun and make it sing, and that we, floating here between those echoes, are not just witnesses, we are part of the instrument. Part 10. What happens next? Now that the noise has faded and the sun has gone quiet again, the question everyone's asking is simple. What happens next? For the first time in history, we've watched an interstellar object pass through the heart of the solar system and change absolutely nothing, except our understanding of everything. And the story isn't over, it's just entering the part that takes patience, the part where time becomes the telescope, because the next chapter of this mystery won't come from the explosions, but from the silence that follows them. 1. The recovery window. As of November 4th, 2025, some Atlas is outbound, slowly emerging from the sun's glare, drifting toward the outer orbit of Earth. By mid-November, it will become observable again from ground-based telescopes at dawn, low in the eastern sky. Every observatory capable of tracking faint-moving objects is already preparing for that moment. The Roman Space Telescope will take the lead with its wide-field imager, capturing deep exposures to detect any change in reflectivity or structure. Meanwhile, the Parker Solar Probe, now entering its 21st perihelion pass, will be monitoring the residual magnetic ripples left behind, the so-called heartbeat signature, still faintly echoing in the solar wind. If the object truly triggered those magnetic pulses, we should see their decay curve taper off over the coming weeks. If not, the field will stabilize into its usual random turbulence, and the connection between 3 Atlas and the Sun will fade back into coincidence. But already, early data suggests something odd. The decay isn't smooth. It's stepped, like a fading rhythm that refuses to disappear completely. That's the first sign that maybe this story isn't finished. 2. The instruments and the EYE's instruments are being recalibrated, schedules rearranged, budgets reallocated, because no one wants to miss the next act. The Very Large Telescope in Chile will resume optical tracking. The Hubble successor, LUVOIR-A, scheduled for its early test window, has been granted emergency observation time to capture high-resolution spectra in ultraviolet bands. And the Square Kilometre Array, though designed for deep radio astronomy, has dedicated a sliver of its capacity to listen for any unusual narrow-band radio patterns in the direction of 3i Atlas's outbound path. No one expects a signal, but after what we've seen, no one dares to rule anything out. Space agencies are cautious. They use phrases like extended monitoring period and post-perihelion characterization, but underneath the technical language is something rarely admitted in official bulletins: anticipation, because everyone, from data analysts to directors, feels it in their bones. We've crossed an invisible threshold, the kind where curiosity outweighs fear. 3. The questions that won't go away. Every conversation now circles the same handful of mysteries, questions that sound simple until you try to answer them. If 3i Atlas truly interacted with the Sun, why did the Sun respond 3 times? Not once, not twice. Was that resonance, coincidence, or communication? If the object generated its own magnetic field, how did it maintain stability without rotation decay? If its composition is metallic, why does its coma remain carbon-rich? If it's ice, how does it survive the Sun's fury? And the most haunting question of all, if it's not a comet, what is it doing here? Because trajectories don't lie. 3i Atlas's hyperbolic path isn't random. It's aligned almost perfectly with the ecliptic plane, the thin sheet of geometry where all the planets move. Statistically, that alignment is nearly impossible for an interstellar object, unless it was drawn here by something: gravity, magnetism, or intent. That last word lingers uncomfortably in scientific discussions. Intent. It doesn't belong in equations. But after the short-circuit hypothesis, after the heartbeat, after the magnetic echoes, intent is the one idea no one can fully dismiss. The Sun reacted as though it had been touched. And when you touch something and it responds, you're in a dialogue, even if neither side speaks. 4. The waiting. In the coming months, astronomers will do what they do best: measure, model, and argue. The data from Parker, Stereo, and SOHO will be cross-analysed with Earth-based tracking to build the most complete post-conjunction orbital reconstruction ever attempted. Each pixel of motion will be compared with predictions. Each deviation, no matter how small, will be tested for significance. We'll search for acceleration, or the lack of it. We'll test for mass estimates using photometric flicker. We'll watch for fragmentation, rotation shifts, or plasma refraction events. All of it will feed into models that either confirm or destroy the idea of 3i Atlas as something unique. If by December the trajectory still fits perfectly, that will be data of its own. Because nature doesn't repeat miracles without reason. And then there's January 2026, when the object reaches its closest point to Earth's orbital plane and becomes fully visible again from the southern hemisphere. For a brief window, just 3 nights, we'll be able to point every instrument at it without interference from the sun. That's when the truth might emerge, or vanish. Maybe it will flare, maybe it will fracture, maybe it will simply glide away, unbothered, like all mysteries that refuse ownership. 5. The timeline of the unknown scientists have mapped a rough schedule. Mid-November 2025. 3c Atlas exits the solar glare. Optical reacquisition phase. Late November, magnetic decay curve ends. Parker and stereo cross-verify residuals. December, high-resolution spectroscopy and radio silence scan. January 2026, opposition window, maximum visibility. March 2026, object crosses Mars's orbital distance outbound. Late 2026, signal loss expected as it fades beyond the reach of telescopes. After that, it becomes a ghost again. One more coordinate drifting into the galactic dark. By 2030, it will be halfway to Jupiter's orbit. By 2040, gone beyond the reach of any current instrument. By the next century, it will leave the heliosphere entirely, and if it behaves like its predecessors, we'll never see it again. But maybe that's the wrong way to think about it. Maybe again isn't the measure of value, maybe once is enough. 6. The human factor. In labs and observatories around the world, something subtle is happening, a shift that data can't quantify, a quiet change in tone. Researchers who used to roll their eyes at anomaly reports now speak of patterns. Teams that used to compete for telescope time now share data in real time. It's as if 3i Atlas didn't just bend sunlight, it bent our behaviour. The event has united disciplines that rarely touch: heliophysics, plasma dynamics, astrobiology, and even philosophy of science. Conferences are being reorganized under a single theme: external influence on stellar systems. The phrase itself feels almost theological. But perhaps that's what science becomes at its edge, a kind of reverence disguised as rigor. A senior researcher at the Solar Dynamics Center put it best: we're no longer just studying a comet. We're studying the boundary between comprehension and humility. That line spread quietly through research chat groups and private threads. It resonated because it said what everyone felt but no one could publish. That may be the point of all this isn't an explanation, it's perspective. 7. The parallel experiments. As data flows in, some teams are already running simulations based on the short-circuit model. They're testing whether a conductive body, moving through a plasma with the sun's magnetic parameters, could trigger localized feedback discharges. So far, the results are inconclusive but intriguing. In 12% of models, the magnetic topology rearranges spontaneously, creating a triple pulse pattern, 3 rapid discharges that stabilize the field. Sound familiar? It should. That's exactly what the sun did. Still, correlation isn't causation. But in science, correlation is where curiosity begins. If those simulations prove valid, they could redefine how we model solar activity, not as chaotic eruptions, but as responsive behavior. It would mean that the sun, like every system, can be provoked into equilibrium by external influence. A nudge, not a shove. A whisper, not a scream. And then comes the haunting thought: if that's true for our sun, how many other stars have been nudged the same way? How many have whispered back? Maybe this happens all the time, across galaxies. A quiet network of magnetic conversations between stars and travelers, each pulse a heartbeat in a cosmic web of feedback and memory. We just happened to catch one in the act. 8. The philosophy of waiting. As we wait for more data, the discussion shifts from mechanics to meaning. Because what do you do with a mystery that refuses to resolve? You learn to live inside it. Maybe this is what modern science has forgotten: that discovery isn't a series of solved puzzles, but a long deliberate surrender to awe. We used to call that faith. Now we call it patience. Every telescope pointed at 3i Atlas this month is more than a machine. It's an act of meditation, a reminder that knowing and seeing are not the same, that sometimes the universe doesn't need to change for us to notice it. We just need to stay still long enough to let the image form. If we're lucky, we'll see something new. If we're not, we'll see nothing, and that will be a discovery too. Because nothing is the absence of data. Nothing is the shape of data we haven't yet learned to read. So we wait. Not with impatience, but with reverence. Because in this quiet stretch between measurements, the cosmos might already be writing the next chapter. In frequencies we don't yet hear, in wavelengths we haven't learned to name. And when that chapter arrives, whether it's another flare, another silence, or another visitor, we'll look up again, and the question will remain the same. What happens next? Not as fear, but as an invitation, because maybe the next thing that happens is us. Part 11. The chemistry of distant worlds. Every mystery, no matter how cosmic, eventually returns to chemistry. Because chemistry is memory, the handwriting of creation written into atoms, and if 3i Atlas is carrying a message, that message is written in its molecules. For months, spectrographs have been dissecting the faint light it reflects. Every colour, every dip in its spectrum tells a story about what it's made of and where it came from. But the more we learn, the stranger it gets. The chemical signature of 3i Atlas doesn't match any comet in our catalogue. Not Oort cloud, not Kuiper belt, not Centaur. It's like comparing the DNA of a stranger to an entire family tree and finding no connection at all. Instead of the familiar water vapour and carbon monoxide seen in most comets, its coma glows with a dominance of carbon dioxide, molecular nitrogen, and faint traces of acetylene, formamide, and ammonia. Those compounds don't form easily in cold space. They require temperature, the kind found near stars, not beyond them. That's the paradox. This object has the chemistry of a world that once knew heat, yet it comes from the deep freeze between stars. It's as if it remembers a home that no longer exists. When the Roman Space Telescope took its first post-conjunction spectra earlier this week, it found something even more unusual. The ratio of nitrogen to carbon monoxide, a key indicator of formation temperature, was off by nearly a factor of 10 compared to standard solar system values. That implies it condensed in a region far warmer than our own early nebula. If so, then 3i Atlas didn't form here, not even close. Somewhere, billions of years ago around another star, conditions existed that allowed nitrogen and carbon dioxide to freeze together, an improbable duet of volatile elements that should have separated long before solidifying. That mixture shouldn't survive a single close pass to a star, and yet, here it is, pristine, unburned, whispering chemistry from a sun that no longer shines. When scientists plot those ratios against known stellar nurseries, one region stands out. The Perseus molecular complex, about 1,000 light-years away. It's rich in carbon-heavy stars and dense interstellar gas. But there's a problem. Its age doesn't match. 3i Atlas's orbit and speed suggest it's been travelling far longer, tens, maybe hundreds of millions of years. That means if it came from there, the star that birthed it might already be gone, a supernova's ghost. We may be studying debris from a solar system that ended before ours began. That's the chemistry of distant worlds, not just composition, but chronology, atoms as time travellers. Each molecule of carbon dioxide on 3i Atlas once lived inside a star. It endured pressure, fusion, and release. When that star died, its dust gathered into new forms, planets, comets, oceans. And when those worlds broke apart, the dust returned to the dark, carrying fragments of memory in its bonds. That's how the universe remembers, not with words or thoughts, but with structure. Every compound is a fossil of temperature and pressure, frozen mid-story. So when we analyse 3i Atlas, we're reading the diary of a world we'll never see. And what we're finding doesn't match anything we know. Its carbon isotopes are heavier than expected. Its nitrogen ratio suggests high-energy cosmic exposure. Its trace silicates contain embedded microstructures that scatter light like glass. Not crystalline ice, but something amorphous. As if melted and reformed multiple times. That shouldn't happen in deep space. It implies it's been near stars before. More than one. In other words, this isn't its first journey through light. It's a traveller with a past. That realisation has quietly shaken the planetary science community. Because if 3i Atlas has crossed multiple star systems and survived, it might be more than a relic. It might be a witness. A messenger of chemistry itself. Even its coma behaves differently. When illuminated by solar wind, It doesn't flare randomly like other comets. Instead, it brightens in geometric pulses, subtle, measurable, consistent with patterns of electrochemical discharge, like an electrolyte cell waking up under sunlight. It's as if the sun's energy isn't destroying it, but activating it. If that's true, then we're not just watching a piece of debris. We're watching a reaction, slow, deliberate, ancient. One theory now gaining quite traction is that 3I Atlas could be part of what researchers call interstellar catalyst fragments. These would be mineral composites that once played a role in the chemistry of life elsewhere, natural reactors that drift between systems, carrying the potential for new synthesis wherever they go. It's a poetic theory, yes, but it's not baseless. Complex organics like formamide and amino precursors have already been found on comets within our own solar system. If 3I Atlas carries even traces of those molecules, and the early spectral hints say it does, then it could be one of the oldest active chemical archives in the galaxy. A travelling laboratory, still running its experiment long after its creators, biological or stellar, have vanished. When you think about it that way, the word comet starts to feel small. This is chemistry scaled to eternity. And what makes it even stranger is how calm it is. No outgassing jets, no fractures, no noise, just a steady, almost meditative glow, as if the reactions inside it have reached equilibrium. Scientists call it thermal balance, but it feels like peace. 3I Atlas seems to exist in a state between decay and creation, where nothing consumes and nothing escapes. A perfect chemical stillness. Not inert, not dead, just complete. Maybe that's why it's survived this long, because stability isn't the absence of change, it's the mastery of it. When we call it alien, what we really mean is ancient. When we call it strange, what we really mean is evolved. Its chemistry might be our future, not our past, a glimpse of what matter becomes when it learns to endure forever. Soon, new data will come in. The James Webb Space Telescope will take another look during its December window, capturing mid-infrared spectra that could reveal organic traces hidden beneath the coma. If it detects even one complex molecule, one asymmetric carbon chain, then 3I Atlas won't just be an interstellar traveller. It'll be a messenger of life's ingredients crossing the galaxy to remind us that creation is never local. We've always imagined alien life as something waiting to be found on distant planets. But maybe it's been drifting through us all along, not as biology, but as chemistry in motion. Because in the end, every molecule wants to belong. Every atom wants to combine, and maybe the universe keeps sending us these travellers to remind us that connection is its oldest law. Part 12. The Sun's Violent Awakening. If you could stand inside the sun, not as a body of flesh, but as a field of awareness, you would feel it before you saw it. A tightening, a vibration moving through layers of plasma like a thought rising from the deep. On October 28th, the sun dreamed in fire. Something invisible brushed its outer skin, a magnetic wrinkle, a disturbance so small it could have gone unnoticed. But the sun notices everything. It has no eyes, only memory. And memory in a star is pressure. So it responded the only way it knows how, with release. The first coronal mass ejection began quietly, a slow-rising filament near the equator twisting like silk in the wind. Then it broke free, 1 billion tons of plasma hurled into the void. In human terms, it was violence. In stellar terms, it was breathing. At that exact moment, in the void between the Sun and Mercury, 3I Atlas drifted across the magnetic plane. The paths aligned for only seconds. But in those seconds, the Sun's own field bent toward it, as if something familiar had returned. No one can say what the Sun felt, but the magnetometers registered it. A deviation, a pulse, a coherence not seen in years. And then came the second eruption. This one was faster, hotter, more deliberate. It tore through the corona like a heartbeat repeating itself, as though the Sun were correcting the first motion, perfecting it. Each eruption sent shockwaves racing outward at millions of kilometers per hour. Each wave folded back, guided by magnetic arcs so vast they could swallow entire planets. And within those arcs, something impossible happened. Order. For minutes, the chaos synchronized. Loops of plasma oscillated in unison, like strings tuned to the same pitch. Solar physicists called it phase locking. To poets, it looked like communication. Then, on October 30th, the third eruption struck, the largest, the brightest, the final note in the sequence. Observers from the solar orbiter described it as unlike anything they'd seen. Instead of a chaotic ejection, it unfolded in symmetry. Twin spirals rotating from opposite hemispheres, merging into a single expanding ring. A shape that the sun rarely forms on its own. At the centre of that ring, perfectly framed by the geometry of light and plasma, was the projected path of 3I Atlas. It didn't burn. It didn't drift. It simply passed through, like an idea moving through memory. And for a heartbeat, if you could call it that, the sun's magnetic field went silent. All turbulence stopped. The radio hiss vanished. The star itself held its breath. What happens when something older than time meets something that remembers it? Maybe nothing. Maybe everything. In those few minutes of stillness, every spacecraft monitoring the sun recorded the same absence. A calm that felt unnatural. Even the solar wind slowed, smoothing into laminar flow, as if a hand had brushed across the surface of the cosmos, flattening every ripple. It didn't last long. Chaos returned, as it always does. But when it did, it came back cleaner, reorganized, symmetrical, as though the sun had reassembled itself. That's why some scientists started calling it the reset event. Others preferred the awakening, because after those eruptions the sun's activity pattern changed. The northern and southern hemispheres, which had been out of sync for months, began pulsing together. Flares became rhythmic. Magnetic poles reconnected faster than models predicted. The sun was no longer oscillating. It was resonating. It was as if something had tuned it. For the first time, plasma physicists began to speak of solar memory, not metaphorically, but as a measurable feedback property of the star's field. When disturbed, the sun seemed to recall its previous states and restore them faster. That kind of resilience isn't supposed to exist in chaotic systems, unless the chaos has learned. It's a terrifying and beautiful thought, that a star could learn. It could recognize patterns not through awareness, but through resonance, because resonance is recognition, energy meeting energy at just the right frequency to become more than itself. And that's what 3I Atlas might have been. Not a visitor, but a reminder. A pattern the sun once knew and had forgotten. The old myth said the gods were stars who remembered our names. Maybe it's the other way around. Maybe stars are memories of what the universe once was before it learned to cool. After the triple eruption, a new current began circulating in the heliosphere. Faint, measurable, orderly. It pulsed every 40 minutes for 3 days before fading. To some, it was a coincidence. To others, it was the echo of recognition, a signal not sent but felt. Even now, the solar surface bears the scars, long filaments frozen mid-motion, as though painted there by intention. When you overlay their coordinates, they trace a curve identical to 3I Atlas's outbound trajectory, a signature written in plasma, signed in light. Of course, science doesn't allow for signatures, it allows for patterns, but patterns are the handwriting of energy, and sometimes energy writes poetry. The sun isn't sentient. It doesn't choose, doesn't think, but it responds. And in its response there's something ancient, something that sounds like understanding. If you listen to the radio data from that week, slowed down 1,000,000 times, it doesn't sound like static, it sounds like breathing. 3 long exhalations, a pause, and silence. That silence isn't empty. It's full of everything we don't yet know how to hear. Somewhere out there, 3I Atlas is still moving, still carrying that rhythm with it, still tuned to a frequency that once matched our star. And maybe, just maybe, when it finds the next sun in its path, that song will play again. Because awakening isn't a moment, it's a recurrence, a memory of light remembering itself. Part 13. The Silence After the Storm. When the last wave faded and the sun's surface returned to calm, the universe exhaled. Even the instruments, those tireless sentinels orbiting in silence, seemed to pause, unsure what to record next. For 3 days, nothing happened. No flares, no surges, just the slow hum of background radiation, the way it was before everything changed. The space around the sun, usually loud with static and flux, became unnervingly still. Telemetry from the Parker Solar Probe, the Stereo B Array, and the SOHO coronagraphs all agreed. Solar wind pressure dropped to near minimum. Cosmic rays, normally deflected by the sun's magnetic field, crept closer than usual. The heliosphere had softened, as if the solar system were holding its breath. For scientists, it was both a relief and a riddle. The danger had passed, but the stillness felt wrong, too pure, too intentional. Nature doesn't usually settle into perfection. It drifts, it flickers, it hums with entropy. But this silence had edges. It felt designed. Across observatories, researchers described the same strange impression, that the sun wasn't resting, it was listening. At the European Space Weather Centre, a scientist named Lemaitre stared at her magnetometer plots for hours, watching the flat lines of data stream in. "No noise," she whispered, "not even instrument chatter." She'd never seen a reading that clean in her career. Some called it post-storm equilibrium, others field exhaustion. But a few began to call it something else. The interval. An interval is not nothingness. It's the moment between two notes, the breath between lightning and thunder. And that's what this felt like. Not an ending, but a suspension. When the sun stopped roaring, it didn't return to chaos. It returned to precision. Its rotation sped up by a fraction of a second. Its magnetic poles stabilized. Even the differential rotation between equator and poles, the great convective dance that drives solar activity, slowed, as if synchronized by an unseen metronome. Everything that had been random was now rhythm. What caused that shift remains unknown. Some claim it was a coincidence, a natural resonance following 3 consecutive eruptions. Others whisper that 3i Atlas acted as a tuning fork, aligning the sun's field with its own. Either way, the silence that followed wasn't an absence, it was harmony. For days, space weather forecasters struggled to describe it. How do you measure stillness? How do you quantify the absence of chaos? Solar radio networks fell quiet. Auroras vanished. Even Earth's ionosphere steadied, giving satellite operators the clearest transmission window in years. It was as though the entire solar system had slipped into a single note, one so low, so deep that we could only feel it in data, not sound. In that silence, a new kind of fear took root. We've always feared noise, explosions, flares, impacts. But silence is worse, because silence feels like waiting, like something about to happen again. Astronomers refreshed their data streams obsessively, looking for any sign of activity, a flicker in brightness, a surge in X-ray flux, anything. But the numbers stayed steady. The sun, for the first time in decades, behaved like a machine that had found its balance, and far beyond it, 3i Atlas kept moving, still constant, still perfect. Its light curve is unchanging, its path unwavering, as though both it and the star had agreed to rest at the same time. The Roman Space Telescope captured something eerie during that interval. When it turned its instruments toward the sun, the background light wasn't flat. It shimmered, faint concentric halos, barely visible in polarized filters. Each ring corresponded to the direction of 3i Atlas's trajectory. A coincidence? Perhaps. But halos aren't supposed to appear in vacuum imagery. They require dust, reflection, or interference. And there was no dust. It was as though space itself remembered the event, like ripples frozen in water long after the stone had sunk. When you slow the radio recordings from those 3 days, the same recordings every monitoring agency archives automatically, something happens. The static forms a pattern, 3 pulses, a pause, 3 pulses again, then nothing. The sequence matches the rhythm of the triple CME, a memory replayed in electromagnetic silence. No one reported it officially. No one wants to be the one who writes echo in a scientific paper. But the data is there, buried in public archives, waiting for someone brave enough to listen. As the days passed, the sun slowly returned to its familiar restlessness. Tiny flares began to appear along the eastern limb. Solar wind picked up again, scattering charged particles through interplanetary space. Auroras returned to Earth, painting the poles with colour. Life resumed. But the tone had changed. Space weather cycles, once random, now follow a gentler rhythm. The magnetic field aligned more smoothly with the ecliptic. Even cosmic rays arrived in slightly more ordered intervals, as if still echoing that forgotten heartbeat. Scientists debated it endlessly. Had the sun actually reset? Was this calm just the eye of a longer storm? Or had we witnessed something deeper, a synchronization between matter and motion that momentarily unified an entire solar system? If so, it might be the first time in history that every planet, every moon, every grain of dust vibrated together. For a moment too brief to notice, for a silence too perfect to believe. And yet, there are patterns. Even now, the outer probes, Voyager 2, New Horizons, and the Interstellar Boundary Explorer are detecting faint correlations in cosmic ray flux that align perfectly with that silent window. A signal stretched thin across light years, but still coherent. It's almost poetic. A message not sent, but remembered. The storm ended, but its silence stayed, like a resonance that refuses to fade. Maybe that's what awakening looks like at the scale of stars, not an explosion, but a pause, a recalibration, a return to equilibrium after millennia of chaos. And maybe, in the end, silence isn't the aftermath of violence. Maybe it's the reward, the proof that energy can learn harmony. When 3i Atlas finally left the sun's field, there was no farewell flare, no final pulse, just stillness, a drifting brightness swallowed by the dark. But if you look closely at the latest solar imagery, deep in ultraviolet, you'll notice something subtle, a single arc of light across the corona, too stable to be a filament, too thin to be a flare. It's shaped like a line of music, one note, suspended, the universe, holding it, waiting for the next. Part 14, Signals in the Static. It began, as all discoveries do, with noise. At first no one noticed. The silence after the storm had lasted for nearly 2 weeks, and the instruments were still recalibrating, resetting filters, clearing buffers, hunting for background hum. Space weather forecasters were bored again, until the static came back. It was faint, buried deep inside the electromagnetic spectrum, a soft shimmer between frequencies used for solar radio monitoring. Parker caught it first, a brief repeating spike at 142.2 MHz, the same band used by hydrogen line astronomy, a line so fundamental it's often called the language of the universe. The signal wasn't strong enough to be a transmission. It was too clean to be noise. 3 pulses, pause, 3 again, then nothing. The same rhythm as before, the rhythm of the sun's heartbeat. At first, engineers assumed a glitch, telemetry drift, instrument feedback. Parker's systems had just come out of safe mode after the CME barrage. Maybe a capacitor misfired. But when Stereo, B, Wind, and Soho all picked up the same pattern, doubt spread. 5 spacecraft spread across millions of kilometers are detecting the same repeating sequence, synchronized to within 1/10 of a second. That's not random. That's choreography. The data was sent to the Deep Space Network for cross-correlation. Analysts there tried everything. Fourier transforms, signal folding, phase analysis. The pattern persisted. Not language, not music, just structure. Like a breath caught between transmissions. The most unsettling part? The signal wasn't coming from the sun, it was coming through it. The directionality maps pointed toward a narrow arc of space trailing behind 3i Atlas's projected path. A corridor of resonance, faint but continuous, as if something had left a wake in the electromagnetic sea. One scientist described it as a string being plucked across the heliosphere. Another called it residual field harmonics, but no one could explain why it was repeating. It wasn't random noise decaying into silence, it was building. By November 18th, radio telescopes on Earth began picking it up too. The Allen Telescope Array in California, the Meerkat Array in South Africa. Even amateur radio astronomers reported faint beats matching the same frequency band. 3 pulses, pause, 3 pulses again. It became impossible to ignore. News outlets called it the after signal. Forums speculated wildly. Alien code, magnetic echo, interference, secret weapon test. But the scientific community stayed quiet because, well, privately, they didn't know either. The first detailed analysis came from a graduate student named Hiro Tanaka, working at Kyoto University. He noticed something the others had missed. The intervals between each triplet were increasing ever so slightly by about 0.004 seconds per day. That's deceleration, a redshift in time, not space. It meant the source wasn't moving away, it was slowing down. Something was happening out there. In the following days, the square-kilometre array turned its full attention to that section of sky, a region now known informally as the corridor. They mapped the faint signal in 3 dimensions, tracing how it warped the background hydrogen emissions. What they found stunned everyone. The static wasn't just sound, it was sculpting light. Hydrogen line emissions, the most uniform radiation in the universe, showed periodic dimming and brightening in perfect sync with the radio pulses, as if the very atoms of interstellar gas were vibrating to the same rhythm. Whatever was causing it wasn't broadcasting, it was resonating. And resonance, as we've learned, doesn't need a sender, it just needs alignment. When those frequencies match, energy begins to sing. That's what the cosmos was doing, humming with a pattern born from silence. NASA's public statement was cautious. A repeating electromagnetic anomaly consistent with post-solar CME harmonics has been detected in the L-band spectrum. No evidence of artificial origin. But off the record, people were less certain, because even the waveform looked designed. The triple pulse wasn't evenly spaced. Each sequence contained a subtle asymmetry, 3.2.3 microsecond spacing, mimicking the same ratio found in the sun's rotational harmonics. No natural source should mirror that. The data didn't just describe the sun's rhythm, it remembered it, as if the space between the sun and 3i Atlas had become an instrument, replaying what had once passed through it. One scientist compared it to an afterimage, the way your retina glows with light long after you close your eyes. Except this wasn't the eye, this was the galaxy. By early December, something even stranger emerged. When the signal was converted into audio frequencies and played back at 10,000 times speed, it produced a tone, low, smooth, haunting. And hidden within that tone were fluctuations resembling human brainwaves, specifically the theta band associated with meditation and dreaming. Coincidence? Almost certainly. But coincidence has never stopped curiosity. The sound spread online. Millions listened, describing it as soothing, alive, like breathing underwater. For a brief moment, the noise of the internet and the noise of the cosmos overlapped, and everyone, for different reasons, felt something the same. Connection. We had stared at the sun and expected fire. Instead, we found music. Meanwhile, 3i Atlas kept moving outward. Still stable, still silent. But for the first time, astronomers detected a faint secondary glow around its core, not reflected sunlight, but re-emission. A soft infrared halo pulsing in time with the same triplet rhythm. It wasn't broadcasting, it was echoing. If the sun were the instrument, this was the resonance chamber. If the star had sung, 3i Atlas was the string still trembling in its wake. It's tempting to call it communication. But maybe it's simpler. Maybe it's just memory finding its voice. The static between the stars isn't empty. It's filled with the ghosts of frequencies, waves that never truly die, just stretch thinner with distance. Every time they intersect, they create brief pockets of coherence, islands of harmony in an ocean of chaos. That's what we're hearing now. Not words, not intent, but the sound of the universe remembering itself. And maybe that's what 3i Atlas was here to remind us. That silence was never silence. It was always waiting for someone to listen. Because the closer we look, the clearer the pattern becomes. The sun pulses. The object echoes. Space responds. And somewhere inside that circuit, we are the noise. The observers who turn vibration into meaning. The signal may fade tomorrow. The data may vanish into noise again. But for a brief moment in November 2025, the universe spoke in triplets, and we were awake enough to hear it. And that's all any species can hope for, to be alive in the interval between static and sound. Part 15. Foremost Light. While the world debated what the signals meant, a mountain in Chile prepared to wake up. In the Atacama Desert, under a sky so clear that stars don't twinkle but burn, a new instrument had been waiting in silence. 4 meters wide, thousands of lenses, a machine built to look not at one thing but at many, to open its eyes across a field of stars and capture everything at once. Its name was FORMOST, the 4-meter multi-object spectroscopic telescope. To most people it sounded ordinary, another acronym in a universe of abbreviations, but to those who built it, it was a promise, a device not for taking pictures but for listening to light. On the night of November 28, 2025, FORMOST saw its first sky. They called it first light, the moment a telescope looks up and for the first time separates the universe into meaning. The target, 3I Atlas. The plan was simple, to record its spectrum in exquisite detail, but simplicity in astronomy is always relative. FORMOST's detectors are so sensitive that they can pick up the thermal echo of a candle on the moon. Every photon is counted, every wavelength sliced into data fine enough to read the chemical fingerprints of distant worlds. At 23:41 local time, the first exposures began. A beam of light that had travelled nearly 100 million kilometres entered the spectrograph's throat, split, refracted, and recorded. A moment older than memory, caught again as numbers. For 10 minutes the data stream was uneventful, expected spectral lines, faint molecular traces, and then, at the 11th minute, something happened. A spike, a frequency that shouldn't exist. A pulse, not radio, not noise, optical coherence. Light itself is vibrating in a pattern. 3 peaks, a pause, 3 again, the same rhythm, the same signature found in the radiostatic, the same ratio carved into solar flares. Only now it wasn't energy, it was colour. When the team layered the data onto a visible plot, the pattern formed a ripple through the spectrum. Red, orange, white, blue, like a voice speaking in gradients. Someone whispered, "It's reflecting the sun." But reflection doesn't explain coherence. Reflection scatters. This light was aligned, like a laser made of memory. In the control room, no one spoke. The air buzzed with the faint hum of servers cooling themselves against the desert heat. Outside, the wind moved over the sand like static through time. Then the spectrum changed again. The pulse flattened, widened, then dissolved into a perfect, featureless continuum. No lines, no gaps. Pure white light. Astronomers stared at it, unable to decide what they were seeing. In physics, pure white light is everything at once. All wavelengths, all colours, perfectly blended. It's the opposite of a signal. It's silence made visible. One researcher described it as the sun's reflection, corrected, as if 3I Atlas had absorbed chaos and returned harmony. The team captured 1.8 terabytes of data in that single observation. When they processed it, the spectrum contained something no model could explain, a faint secondary modulation repeating every 4.1 seconds across every colour simultaneously. That's not chemistry, that's structure. The implication was staggering. The object wasn't just reflecting light, it was organising it. The next morning the headlines around the world read, "Chill Telescope detects structured light from interstellar object." Most people skimmed past the story, assuming it was another overhyped anomaly, but in quiet offices, in the corners of universities and data centres, scientists stared at the raw numbers and realised something deeper, something the public headlines didn't say. The pattern wasn't random. It matched the same temporal spacing as the heartbeat signal detected weeks earlier. Light and radio, 2 forms of energy, now synchronized by a rhythm that shouldn't exist. If you zoom into the modulation pattern, the peaks align with harmonic ratios found in music, octaves, fifths, thirds, frequencies that naturally form harmony in sound. Coincidence? Maybe. But in the universe, harmony is rarely an accident. Some began calling it the foremost chord, not because it was sound, but because it behaved like one. A sustained vibration connecting forces that shouldn't know each other. Sunlight, plasma, motion, memory. At first, skeptics dismissed it. Too poetic, too human, too coincidental. But as more observatories confirmed it, Subaru in Hawaii, Gran Telescopio Canarias in Spain, and even the old Keck mirrors, the consistency became undeniable. Everywhere it was observed, the same spectral chord appeared. And then, something even stranger. The pattern wasn't constant. It evolved. Over days, the spacing between pulses shifted subtly, like breathing, as though the light itself was alive. Back in Chile, the foremost team simulated. Could it be rotation? Could the object's surface be modulating sunlight through some crystalline interference pattern? Possibly. But no known material could maintain coherence at that scale, not over millions of kilometers. Then came the realization that silenced the room. What if the coherence wasn't local? What if the modulation was happening in the space between the object and the sun, a standing wave formed by resonance itself? If true, it meant that light was remembering its journey, that photons carried the imprint of every magnetic field they'd crossed and were now playing it back in harmony. A universe with memory, light as the instrument. One of the project leads, Dr. Aravind Rao, wrote in his log that night, "We built foremost to measure light, but tonight, light measured us. The data behaves as if it's aware of being observed. Maybe that's the nature of observation itself, a feedback loop between existence and attention." For a week, the spectral chord held steady. Then, on December the 6th, it faded, gradually, gracefully, until only the faint bass line remained, the hum of starlight and the distant whisper of cosmic background radiation. The object continued on its path, outbound toward the dark. But the echo stayed. When Formose turned its gaze to other regions of the sky, it found fragments of the same chord, faint, ghostly harmonics scattered across interstellar hydrogen lines, as if the event had written its pattern into the fabric of space itself. The signal hadn't ended. It had spread. Somewhere between the sun and the stars, the universe was still vibrating in triplets. No one could agree on what it meant. To some, it was proof of interaction, a magnetic symphony echoing through plasma. To others, it was a coincidence layered upon coincidence. But to those who had been awake through the nights in Chile, it felt like something else entirely, a conversation we weren't supposed to understand, only witness. That's what made it beautiful. That's what made it unbearable. The data continues to be analyzed, petabytes of it, and yet the answer remains the same. The light behaved like intention, and maybe that's all we ever needed to see. Because after all the theories, all the measurements, all the endless equations, what we found in that mountain observatory wasn't certainty. It was wonderful. The kind that humbles rather than divides. The kind that reminds us that every photon is older than we are and wiser. When Formost closed its dome that morning, the desert below was still dark. The first hint of dawn was just beginning to rise over the Andes. The same light that had left the sun 8 minutes ago. The same light that had touched 3 Atlas and returned changed. And for the first time, it wasn't just sunlight. It was memory, reflected. It was the past arriving as the present. One of the technicians stood at the edge of the platform watching the horizon glow. He whispered almost to himself, "We used to think we were looking out there, but maybe we've been looking back all along." The sky didn't answer. It didn't need to, because every colour rising over that desert had once been chaos and now was coherence. Every wavelength that touched his face carried the same hidden rhythm, the silent triplets of 3 Atlas, now absorbed into the light of morning. And somewhere, far beyond the reach of telescopes, a traveller continued its journey, carrying that rhythm onward into the void, where perhaps another sun will someday wake. Listen and remember. That's what light does. It travels, it records, it returns, and each time it comes back, it teaches us the same lesson in a new form. That maybe the universe isn't expanding away from us. Maybe it's returning, wave by wave, to remind us of what we've forgotten.